Prove each statement in 16 through 19 by contradiction. For all prime numbers a, b, and c, a squared plus b squared does not equal c squared. So according to the law of non-contradiction, either this statement is true or the negation of this statement is true. Since we're trying to prove this statement, it's probably because the statement is true, which means the negation of the statement is false. The goal of a proof by contradiction is to assume that the negation of the statement is actually true, even though it's false, and then eventually lead to a blatant contradiction. And that contradiction will directly contradict the assumption at the beginning. So before we get into the proof, let's first address what the negation is. Since the original statement was universally quantified, that means the negation is going to be existentially quantified. So there exists prime numbers a, b, and c such that a squared plus b squared equals c squared. When negating this universally quantified statement, we have to negate this propositional statement on a, b, and c. So we flip this does not equals into an equals. So this is the negation. Once we've identified the negation, the proof by contradiction comes when we assume that there exists prime numbers a, b, and c such that a squared plus b squared equals c squared. Since we're assuming the negation of a true statement, that means we're assuming a false statement. And you should never assume a falsehood, because if you ever assume a falsehood, then you'll end up with logical contradictions. So now our goal is to bring out the logical contradictions that result when we assume this falsehood. Now, if we subtract b squared on both sides of this equation, we get a squared equals c squared minus b squared, which by algebra, and I'll put ALG here to point out that this equality is due to an algebraic property, we can factor this quadratic as c plus b times c minus b. Now, according to the unique factorization of integers theorem, the number a squared is the only way we can factorize this number. A is a prime number, and so a squared is already written in standard form. So a squared is really my p1 to the e1. But since this factorization is unique, and c plus b is not equal to c minus b, since b is non-zero, it's a prime number, so it can't be 0. Since these two numbers are different numbers, then we have a squared as a multiplication of two different numbers, and so we have two factorizations. So this is a contradiction. And so what did we contradict? Since all of this logic is valid, then the only thing we could have contradicted is our assumption that there exists prime numbers a, b, and c that satisfies the Pythagorean identity. That means we must have assumed a falsehood. And since this statement is a falsehood, according to the law of non-contradiction, that means this statement is true. The negation of a falsehood must be true. Thanks, everyone, and I'll see you in the next video.